Alright guys, in this video we're going to be taking a look at some properties of logarithms, and these properties are going to help us to expand as well as simplify some problems that include logarithms. So we're looking at a total of 3 properties. Alright, you're probably going to want to jot these down in your notes. So our first property that we're looking at is, what if we have log base b of x times y? And just note with this log base b, guys, it could be any base here. All right, so if it's natural log, the common log, log base 6, whatever it may be, this applies to all logarithms no matter what the base is. And so if we have log base b of x times y, we can split that up into log base b of x plus log base b of y. All right, so if we're multiplying two values in the same parentheses, we can split them up by using two separate logs with addition. And of course, vice versa is also true. So if we have log base b of x plus log base b of y, we can condense that and simplify it by writing that as log base b of x times y. All right, the second property we're looking at now is, what if we had division here? We have log base b of x divided by y. Well, we can split this up by writing it as log base b of x minus log base b of y now. All right, log base b of x minus log base b of y. So we're splitting it up, and this time it is subtraction. And of course, you can still go vice versa. If we're trying to simplify, and you have log base b of x minus log base b of y, you could put that together in the same log with a division sign. All right, in our last property, for this one, we have log base b of x to some power. All right, whenever we have to some power, what we can do is take that power and write it down out in front and write it as a times log base b of x. All right, so that power rule with logarithms is we can take that power and write it down just out front. Let's just kind of see this. Let's see an example of this. Let's say that we have, let's do the common log of 100. All right, well, I know that 100 is 10 squared, so I could write that out in front as, well, let me write this as log of 10 squared. I could write that out in front and say that's going to be equal to 2 times the log of 10. And of course, we know that's true. Log of 100, that asks us 10 to what power equals 100, so that's just going to be 2. And if I have 2 times log of 10, well, log of 10, 10 to what power is 10? That's 1 times 2 is also 2. All right, so we can see that this works here. We can take that power, bring it out in front, and vice versa. If we're trying to write it and simplify it, okay, we could take the a that's multiplying log base b of x and put it inside as an exponent. All right, so let's just give this a shot here. We want to expand log base 5 of x squared times y cubed over z. All right, so we can start off by writing that as log base 5 of x squared plus log base 5 of y cubed, and then minus log base 5 of z. All right, and notice that the base stays the same. So because we started with log base 5, we cannot change that base. It stays as log base 5. Then it's x squared plus y cubed because those two are multiplying each other. And then we are subtracting by log base 5 of z because inside of the parentheses, we were dividing by z. And so now if we want to expand it just a little bit further, we can pull those exponents down in front. So it becomes 2 log base 5 of x plus 3 log base 5 of y minus log base 5 of z. All right, and this right here would be our final answer. All right, most of the time we're going to be using these to simplify, right? Expanding might help us sometimes, but simplifying is probably even more important. So let's try 2 times the natural log of x plus 3 times the natural log of y minus the natural log of z divided by 2. So unfortunately, I'm realizing this is really similar to the last example I just gave us, but let's just practice going in the opposite direction. This is going to be the natural log of x squared. So I'm just taking that 2 out in front, plopping it as an exponent, plus the natural log of y cubed. And then here, minus o. What is this dividing by 2 doing? Let's just think of it as multiplying by 1/2. All right, so then we're going to have minus the natural log of z to the 1/2. And hopefully we remember our exponent rules and we can remember, oh, z to the 1/2 is just the square root of z. All right, well now let's combine these and write them as one natural log. So the natural log of x squared times y cubed, and then over z to the 1/2, which of course is just the square root of z. All right, so we've got x squared times y cubed divided by the square root of z. That's how we are going to simplify this expression. Let's do one with numbers here. What if I have log of 25 plus log of 4? Well, I can combine these by multiplying and say that's going to be equal to the log of 25 times 4. And 25 times 4, that gives me 100, so I have the log of 100. Well, log of 100, 10 to what power equals 100? 2. All right, so log of 25 plus log of 4, even though both of these numbers by themselves, those are both irrational numbers, when you add them together, we get this perfect integer of just 2. So it's pretty cool how that works. And one more example, let's just do a quick multiple choice question. Log of 1/4 is not equivalent to which of the following? We've got 1 divided by log 4. We've got negative log 4, log 1 minus log 4, I forgot to end the parentheses there, and then negative 2 log of 2. Well, let's start with log of 1/4. If I start with log of 1/4, I could immediately write that as log of 1 minus log of 4. All right, so we know it's equivalent to c, so that's not our answer. Well, what's log of 1 equal to? Log of 1, 10 to what power equals 1? 0. Hopefully we remember log base anything of 1 is going to be equal to 0. So that's 0 minus log 4. Well, 0 minus log 4 is just negative log of 4. All right, negative log of 4, that's b, so it's not b. And so we narrow it down to a or d. Well, let's see, we could rewrite 4 as 2 squared. And using the power rule, we could take that 2 and write that out in front. So negative 2 log of 2. So it is definitely equivalent to d. It is not equivalent to a. So that is our correct answer. Best of luck on the homework, guys. I hope that this video on the properties of logarithms helped you out.